All right, folks, we are live. So, hey, Phil Zito here. Welcome to SBA TV episode 28. And in this episode, we're going to actually be starting a multi-series or multi-episode series on HVAC control. So, over the next couple sessions, we're going to talk about space control, psychrometrics, airside pressure, chilled water, hot water, etc. My name is Phil Zito. I'm the founder and CEO of Smart Buildings Academy, where we provide online training resources for people looking to learn building automation and everything associated with building automation. So we're going to hop right in. We're going to go over to the whiteboard and we're going to take a look at some space control concepts. Because at the end of the day, and a lot of people ask, why do you start with space control? Why do you hammer space control so much? And the reason why is because at the end of the day, if you think about your troubleshooting calls, if you think about where you get held up on projects, yes, you have your gigantic systems, your air handlers, your central utility plants, but typically there's one central utility plant in a building. Typically there's maybe a dozen air handlers, but there's hundreds of terminal units, hundreds of spaces. And most of our troubleshooting calls, most of our issues are going to have to do with test and balance in the space. They're going to have to do with troubleshooting in the space, customer complaints in the space. And so we really want to understand a lot of key concepts related to space control. So that being said, let's dive in. So space control, right? Spaces. If you imagine a space, this is, a cubic space like the film studio I'm in here. And within this space, we have airflow coming into the space. Now, we'll talk about how that air gets into the space, and you'll have to forgive if there's a lot of background noise. My kids are home and they're doing like a straw war contest upstairs. They're building straws together with tape for some reason, and I hear them running around, and I'm sure they're going to come down here screaming. That being said, though, what we are trying to control within the space, a lot of people will think maybe it's temperature, right? Maybe it's relative humidity. Maybe it's even CO2. But I will argue that none of these matter if we don't control airflow into our space. So how do we control airflow into our space? Well, there's three main ways that we do it. We either do it through like an AHU, right? An air handling unit. And an air handling unit may be 100% outside air, maybe a mixed air unit, maybe a packaged rooftop, right? So this unit going directly into the space, feeding directly into the space, a one-to-one relationship. Something like a fan coil unit, which that you'd maybe see like in a data closet, things like that, and that's a self-contained unit. It's usually actually in the space itself, either a vertical or horizontal stacked fan coil unit, and those tend to serve interior parts of the building that have high potential loads, but don't justify necessarily having a dedicated air handling unit or rooftop unit. And then we have a terminal unit, a VAV box, in conjunction typically with an air handler. Those are our three ways of getting airflow into the space. Now, regardless, the air is going to flow into the space through a diffuser. Now, this may be a floor mount diffuser in the case of underfloor, right? We may have underfloor diffusers, or we may have overhead diffusers. Now, when the air is entering the space, right, it's entering the space and it's supplying air into the space. CFM, cubic feet per minute, is the measurement we use, at least in the United States, and we have a cubic volume in height, width, and length of the space that we are trying to fill with air. And then the air is exhausted, and the air is exhausted out of the space either using an exhaust fan, either using a return into an air handler, dampers, and just simple pressure control. There's a variety of ways. But what happens when we supply enough CFM to fill this cubic mass of space, and then we exhaust that same amount of CFM, that is called an air change, right? And so air changes are what enable us to change these variables in our spaces. The temperature, relative humidity, and CO2, those are changed by introducing conditioned air into the space. Now, yes, you do have other things like unit ventilators in the space. You do have things like radiators, you have things like floor heat that can all impact these variables as well. But if we're looking for primary variables that we're going to encounter across most of our systems and most of our buildings, then we are looking at a typical, air handler, unitary system supplied to a space, a fan coil supplied to a space, or a terminal unit supplied to a space. Now, we match our outflow in what's called volumetric matching, or we do an offset in what's called volumetric offset. Volumetric matching is the same amount of air that goes in, goes out. Volumetric offset is the amount of air that goes in. There's typically going to be more or less than what goes out, and that creates a positive or a negative pressure environment. We'll talk more about air pressurization in a later SBA TV video. That being said, we're primarily focused on making sure we get our air into the space and get it out of the space so that we can then impact these variables over here on the right. So temperature, and these variables directly correlate with these units up here. So the CFM, which is kind of the overall variable that we are controlling, our airflow, that directly correlates with either the VAV box or the AHU/FCU. And for a VAV box, we're going to stroke dampers inside the VAV box and regulate the airflow. And then you're going to have airflow potentially regulated at the air handler, depending if it's constant volume or variable volume. Now, so that's the VAV, right? At the air handler, if we're directly dumping air in there, we'll either vary the fan speed or the fan frequency to modulate airflow, or we'll just do a direct constant volume airflow. And with fan coils, we will typically go and have a low, medium, or high speed that will be set by the balancer along with some balancing dampers. Now at these variables right here, temperature, relative humidity, and CO2, with temperature, we're typically controlling that with our SAT/DAT, our supply air temp, discharge air temp. And that is usually modulated at the fan coil or the air handling unit via some sort of heating or cooling. Now, granted, at terminal units, you can have heating as well, but at the fan coil, you'll typically have hydronic cooling and hydronic heating or electric heat. At the air handler, you can have all sorts of things. You can have DX cooling, you can have hydronic cooling, you can have electric heat, gas heat, steam heat. There's a variety of things you can do. And you condition that supply air, discharge air temp, and based on whatever your sequence is, whether you're doing a reset, which would be in like a constant volume scenario where you're doing 55-65 reset, or in a variable volume scenario where you're doing 55 and just driving the saturation so you can bring the humidity down and kind of control the temperature. When we talk about relative humidity, and we'll cover this much greater detail in our psychrometrics video. I think the psychrometrics video is the very next video. So what we're going to be doing is we're going to have relative humidity. I hear music blasting on our Alexa. Hopefully you all are not hearing that music. Relative humidity, right? That is going to be controlled by typically either a decascent wheel, or we're going to drive the temperature down to saturation. If you think about psychrometrics, you drive to dew point, you continue to subcool, you warm back up the air, you're at a lower relative humidity. And so we're going to do that with just our humidity control in our AHUs typically. And then CO2 is typically going to be controlled with a outside air damper, and we're going to be modulating that either with demand ventilation or a minimum damper command. But at the end of the day, if you go and you have a troubleshooting call, customers saying the space is hot or the space is cold, we've covered this in our troubleshooting videos in the past, but what I want to encourage you to do is first isolate, is it a single space or if it's multiple spaces? If it's multiple spaces, it most likely has zero to do with the space control sequence and has to do with like the air handler or the central utility plant. If it's a single space, then it most likely has to do with the space sequence. And in that case, we want to understand first that our air changes and our air volume are what are going to cool the space, heat the space, impact the relative humidity of the space, impact the CO2 levels of the space. So we want to make sure that we have air volume properly controlled. How do we do that? If we kind of blow this up right here, what we would see is we would see a diffuser, right? We would see that going into like a balancing valve, going into, or balancing damper rather, going into a VAV box. That's typical control, right? So our checkpoints are, do we have the right CFM coming out of the diffuser? If we don't, then we are going to move to, right, that balancing damper, and we're going to see if that's set properly. And if that's set properly, then we move to our VAV box, and we're going to check our pitot tube, make sure that's right, and make sure that our damper actuator is properly sealed, or our damper blades are properly sealed, and our actuator is properly stroking the damper shaft, and that we're controlling. A quick way to check that is to do 100% command on the VAV box, and we should get somewhere close to the max CFM for that box. Granted, it's going to be a little bit off, especially if you have a variable air volume unit, because you're not going to have full flow. That flow is also going to be diverting to other terminal units, so we got to be cognizant of that. But by troubleshooting airflow, you will real quickly determine what your issue is in a space. That's almost always the issue, is something to do with airflow. Either, smoke damper's blocked before the VAV box, or something's messed up after the VAV box. If it's a single space issue, sometimes it can be a tenant improvement, and you go and you improve the space, and you start using it for computers now, whereas it wasn't designed for that heat load, and you can have issues like that. Or maybe they redesign the space and now you've got giant southern exposed windows that aren't glazed, aren't properly shielded from the solar gain. That can be an issue, but those are outliers. Normally, it is almost always something to do with CFM. So I'm going to hop back over at the screen, see if we got any questions, see what I can answer about space control. If you get this right, if you really understand space control, it's like a linchpin knowledge point for everything else. So space control is going to directly impact pressurization and psychrometrics, and they're going to be interrelated, and those are going to bundle up into air handling unit controls, and that's going to all bundle up into pumping and piping systems as well as hydronic plants, so both boilers and chillers. So if you build these concepts up, that's how we like to teach in our control sequence fundamentals. That's how we teach HVAC sequencing, is kind of stack those knowledge up, and that's what you're going to be getting over the next several SBA TV videos, is we're going to be going through this. All right, so I'm going to walk over, see if there's any questions, and then we'll come back to the whiteboard, see if I can answer them for you. All right, so what questions can I answer for you all about space control? It's a relatively simple concept, space control is. It's not terribly difficult, but at the same time, it's not necessarily the easiest concept to understand. If you think about it, the real variables you're using are the CFM coming out of the diffusers, especially with the VAV box, and if you have multiple diffusers off that box. And that CFM out of those diffusers should add up to whatever the CFM is, plus or minus a little bit, that is being discharged from that VAV box, right? The other factors that may be wrong are things like your calibration factors, box sizing factors. A lot of the newer controls, you don't have to put in box size, you just have to put in a calibration factor. I don't know how I feel about that, to be honest. I came up in the school of where we would enter box size and our K factor to go and determine things. Nowadays, you can kind of get away with that. Box curves for CFM are pretty predictable. They're not always predictable. They're kind of like fan curves, but a little more reliable. You can, for example, go to a Titus website and look at the CFM curves for their boxes based on the box size. When you do get away from cooling only and reheat only boxes and go to series and parallel fan power boxes, things get a little bit different, because now you're dealing with the plenum and you're dealing with booster fans, depending on, right, if you've got series, it's a booster fan. If you've got parallel, you're dealing with plenum as an alternate heat source. So you just need to be cognizant of that. But at the end of the day, right, temperature is not your main variable to control. I know that's like blasphemy, but it's not. Humidity is not your main variable to control. Even if you're in a museum, humidity is not your main variable, and you may be like, Phil, that's a load of crap, because we have like 0.1% tolerance on relative humidity for some museums. I get it. I've done museum work. But at the end of the day, none of that matters if you can't supply the right CFM. So if I hammer one thing again and again and again that I hope you all hear, it's supplying the right CFM to the space. That will eliminate a lot of your problems. You can get a lot of forgiveness in bad plant design. You can get a lot of forgiveness in design days. You can get a lot of forgiveness in thermal comfort by oversupplying airflow. We all know ASHRAE 55, right? It's how set points are determined. It goes into, basal metabolic rates for spaces, how much metabolic rate is going to impact the space. Are people like working out in a gym, or are they sitting their butts on chairs in offices? And based on that, based on ambient, based on solar gain, etc., you come up with set points and you come up with load calculations. Well, ASHRAE 55, one of the things they hammer really heavily is the impact on human comfort of airflow. Airflow can actually offset, and it depends on which study you read, but can offset up to 4 degrees of dry bulb temperature by having proper humidity levels granted and having airflow to take advantage of that evaporative effect. Because remember how humans cool, we sweat and then air flows across our skin, and that air, right, evaporates the sweat, which through that state change of evaporation or phase change of evaporation, we remove BTUs from our bodies. That's why, people say, oh, it's a dry heat in Phoenix. I still think it's hot, but that's why you can feel cooler over there than you could at the same ambient temperature in, like, say, Houston, because the moisture level's so low that you can really maximize that evaporative effect. So if you learn anything from this, if you're trying and you're dealing with a system that's maybe antiquated and you just can't get proper temperature control, if people are hot, increase airflow. It will make them feel cooler. It'll also dry them out potentially, so watch humidity because you don't want to go and have people start having nosebleeds. If people are cold, you can slow down airflow, and that will naturally make them feel hotter because they will evaporate less. But then watch humidity build up and watch CO2 build up. So I'm not saying necessarily to solve bad design and capacity issues by lowering and increasing airflow, but I'm just saying that you can. Obviously, try to fix the capacity issues, try to fix the design issues. But if you're in a pinch, that's something you can do. There's a tremendous amount of effect on the human psyche by just feeling air flowing across them or not feeling air on whether they feel hot or cold. So just kind of a trick I've picked up over the years. So what questions can I answer for you all? I do want to point out that we are in the middle of our tax day sale. So if you haven't taken advantage of that yet, I know a lot of people often reach out to us and they want to purchase our courses and they explain, hey, Phil, I want to buy your courses, but it's just me. I'm buying it myself. Well, then I encourage you to check out our tax sale. Use the coupon code TAXDAY. That will be till the 15th. And you will be able to save 20% off our courses. And remember, any of our courses, you can do the split it payment where you can pay over 12 months. So if you've been considering buying a course, I encourage you to do it before the 15th because the next sale I think we have is maybe Labor Day, but for sure Thanksgiving. So if something you're trying to save money, this will be your last opportunity before summer work begins to go and learn programming, design, IT, troubleshooting, etc. So I encourage you to check that out. All right, so L has a question. Let's take a look. What is an overall building pressure number? It depends. Let me see if I can pull that up for you. There's a document I want to pull up for you. Bridge pressure. I think it was this. Was it this? I think it was this one from Yes, this is it right here. Here you go, buddy. This is a really good paper. It's going to go way deeper than you probably wanted to go, but it gives you kind of a analysis of static pressure and where people are at. It also gives you some benefits on pressure control. So that's good. Here's another one that I'll share with you. This is a good one as well. It talks about kind of just all the different effects of pressure. So you can kind of see. There's no real answer necessarily, because if you are a building that is in the middle of the plains and you've got huge wind effect on you, and you're a healthcare and you're quarantined, you're going to have a completely different pressure scenario than, you know, if you're an open atrium art studio or if you're a school district. So it just depends. I hesitate to give values, but typically anywhere between 0.005 and 0.015, somewhere around there. I've seen much higher and I've seen much lower as far as static pressure values go. But we'll talk about pressurization. I think we're talking about that on the 14th in SBA episode 31, which will be on pressure control. What other questions can I answer for you all? Once again, I just want to remind you that this is just one of a 6-part series on HVAC controls, or HVAC control. And this is space control. Next Wednesday is psychrometrics. I will caution you, I'm getting my second COVID shot on Tuesday night. So depending on how I feel, we may not do Wednesday. If I get smacked really hard by it, my wife got smacked really hard by the side effects of her COVID shot. She had like a 103 fever and body chills and just like was feeling bad. If that happens to me, then I possibly will not do Wednesday. I mean, this doesn't take that much effort to do. So as long as y'all don't mind seeing me sweat, we'll probably still do it, but who knows? We'll see. What else? I talked about the upcoming videos. Talked about the tax day sale with the coupon code. What else did I not mention? We're going to be doing a podcast episode tonight/tomorrow morning on just continuing to answer questions that our customers have asked us about building automation, purchasing building automation systems. So we are going to be covering, if I get to it, let me bring it up here. We're going to be covering these questions. What is a cloud-hosted BAS? How should I change my BAS post-COVID? We're going to talk about, can I implement a touchless BAS and temperature control, and how? How do I get my operators to use analytics? Should I get a BAS or just use smart equipment? How important are mobile-friendly graphics? How do I determine what level of cybersecurity I should have? Should I have multiple systems on my campus? Why or why not? How do I manage contractors if I do owner direct work? How can I build a BAS standard? What is the most important area for me to spend my money on a BAS? How do you balance comfort with energy efficiency? Should customers know how to program their BAS? What are the most common troubleshooting issues? How do I budget for BAS projects? How do I avoid being locked into a single contractor? And should I integrate multiple systems into a single pane of glass? We're going to be talking through all of that in this week's episode, which I will be recording tomorrow because got kind of messed up on the Christmas or the Easter holiday, kind of messed up my schedule a little bit. If you all have a question about anything related to building automation, you know you can always post it in the comments. You can always email us at marketing@smartbuildingsacademy.com and they will get that information to me. And if you don't mind, if you find these videos useful, go to subscribe and then click on the bell. And by doing that, you will not only get notified of all new videos, but you will also help with the algorithm, which will bring more people to the channel, which will drive even more videos because we will continue to invest in this as more people attend these videos. So thanks so much for being here, everyone. As always, you can never hesitate to reach out to me. I look forward to hearing from you. Thanks a ton, and I hope you all have a great rest of your night. Make sure you take advantage of that course sale that's going on to the 15th. If you're at all interested in a course, it's 20% off with the coupon code TAXDAY. That's one word, Tango Alpha X-Ray Delta Alpha Yankee. So tax day. All right, thanks a ton, and you all take care.